Welcome to Feynman's tanx. Today we are going to evaluate two familiar integrals. These two integrals are both evaluated from 0 to power over 2 and then tangent power of something x minus 1 over ln tangent x. So the first one is square root of tangent x, which is tangent x power of 1/2, right? And the second one is tangent x power of I, which is really cool, right? And some of you even ask, can you even integrate functions in definite integral? In definite integral to split word. So tangent power of a ix. Can this integral even can be evaluated? Yes, the answer is yes. So I'm going to use our Feynman's tanx here. Integral from 0 to power over 2. That r of a is equal to integral from 0 to the power over 2 tangent power of a x minus 1 over ln tangent x. And then differentiate both sides, which call I of a. I of a is equal to integral from 0 to power over 2. And then integrate, because we are in the a world, tangent x, which is just a constant. Whenever you do a derivative of a constant raised to a in our a world, which is just keep the original and then time the ln constant, which is ln tangent x, and then differentiate -1, you get 0, and then over tangent x, and then ln tangent x, they cancel each other out. So what's the integral from 0 to power over 2 of tangent power of ax? I'm not going to show you in this video because it takes a lot of time here. So which is pi over 2 secant pi a over 2. So I may do this integral from 0 to power over 2 tangent power of ax in my future videos for you guys. So we are going to integrate back. So which is pi over 2 times the integral of secant pi a over 2 dA. How? Yes. How can we do this integral? Use up in our head. Let u is equal to pi a over 2, which du will give you pi over 2 dA. So we get integral secant u du. Integrate secant, you get ln secant u, which is secant pi over 2, because we let u is equal to pi a over 2, and then plus tangent pi a over 2 plus c. Don't forget plus c here, and then whenever we do a Feynman's tanx, we always don't let a is equal to a negative number. So this a can either be equal to 0 or greater than 0 or just greater than 0. Yes, just greater than 0. In this case, when we plot a is equal to 0, which is tangent power of 0, which is 1 minus 1, that integral will give you 0. So whenever a is equal to 0, that integral will converge. So we can let a is equal to 0 and then greater than 0. So here we are going to figure out what's the constant c here. We are going to let a is equal to 0 here, which is I of 0. We already done that, which is 0. The ln secant 0, which is 1 over cosine 0, which is 1. Plus tangent 0, which is 0, c, plus c. So you can get 0 is equal to ln1, which is 0. 0 is equal to 0 plus c. So our constant c, which is just equal to 0. So therefore, I of a is equal to ln secant pi a over 2 plus tangent pi a over 2. So our first question, the integral from 0 to power over 2 of tangent x minus 1 over tangent ln tangent x, which is just equal to, look at this, which is 1/2, right? We are square root. So I of 1/2, which is ln secant pi over 2 times 1/2, which is pi over 2, pi over 4 plus tangent pi over 4, right? Pi over 2 times 1/2. So secant pi over 2, which is the reciprocal of cosine pi over 4, which is 1 over square root of 2, is reciprocal, which is just square root of 2 plus tangent pi over, which gives you 1. So our answer is ln square root, or ln parentheses square root of 2 plus 1, which you can write this as our inverse sinh 1, which is our inverse hyperbolic sine 1. Yes. So y inverse hyperbolic sine 1, which is also known as inverse sinh 1. Why? Because the definition of inverse sinh x is equal to ln parentheses x plus square root of x squared plus 1. Because the inside is always gonna be positive, so we can just ignore the negative side. So ignore the positive side. Absolute value, yes. So whenever you put a 1 inside the x, you can get ln 1 plus 1 squared plus 1, which is 2 square root of that, which is just equal to inverse sinh 1. So ln 1 plus square root of 2, which is just this. So the first answer is just inverse sinh 1, which is really cool. And our second integral, the integral from 0 to pi over 2 of tangent pi of I x minus 1 over ln tangent x. This integral will give you what? Just put I into the I of A, which is I, which is ln secant pi I over 2 plus tangent pi I over 2. So what is secant pi over 2, which is 1 over cosine I times pi over 2. We can write this as. So cosine I times something which is just our quash. Remember this formula. Cosine I times something which is quash something, which is quash pi over 2. 1 over quash pi over 2, which is secant pi over 2. So over you get secant pi over 2 here. And then tangent I times something will give you I times tanx pi over 2. Yes. And here we can simplify this thing even more. A plus IB, which is the same as A plus BI, our compass. We are going to transform this into our polar form, which is square root of A squared plus B squared times e power of I times inverse tangent B over A. This formula, I think this work for memorizing for you guys. This formula. So we can just adapt this formula. You can get square root of secant squared pi over 2 plus tan squared pi over 2 times e power of I times inverse tangent B, which is tan pi over 2 over secant pi over 2. So secant square x plus tan square x will give you 1. This formula, this one will give you 1 here. Remember this formula? The square root of 1, which is 1. 1 times that, which is e power of inverse tangent, e power of I times inverse tangent. And then tanx, we can write this as secant, sinh pi over 2 over quash pi over 2, and then 1 over secant pi over 2, which is just quash pi over 2. This and this cancel out. Finally, we can just left this with secant pi over 2. Yes. And then ln and e, they just cancel each other. So therefore, our final result, which is I times inverse tangent sinh pi over 2. Yes. We can just leave this result. Yes. However, though, we can also, there is a interesting function which is called gd of x. The Grandemanian function, this called gd of x is equal to inverse tangent of sinh x. So therefore, this inverse tangent of sinh pi over 2, we can write this as I times gd pi over 2. Yes. So here is just our result. Really cool result, right? I times gd pi over 2. So I hope you guys enjoyed this video, and please comment down below, and you can comment down the further integral you want me to evaluate and buy. Really cool. The first result is inverse sinh 1. The second result is I times gd pi over 2, which is the same as I times inverse tangent sinh pi over 2. Yes, really cool. Right?